This is House Planning Help, episode 371. Hello, I'm Ben Adam Smith, and this is the podcast for you if you're interested in self-build or retrofit. I'm exploring what houses we should be building in the 21st century and trying to break down some of the major roadblocks that may get in our way. Coming up in this session, my guest is Chris Brookman from Back to Earth. We're focusing on natural fibre installations and specifically wood fibre in this episode. He's also used this in a big way on his own project. So we'll find out about how it's manufactured, the various characteristics, and what it really does well on a project like this or a retrofit. And I've got to know Chris through the Alliance for Sustainable Building Products. Of course, we're talking materials and lovely materials. He's a member of the ASBP, so it seems like a good idea to feature them as our resource for this episode. Also, each year they gear up for their big event at the start of the year, the Healthy Buildings Conference and Expo. That's definitely worth having a look up on their website. We'll put a link into the show notes in case you want to head along. And part of that is also an award ceremony. So I was just thinking, whatever time of year it is, you could also head on to their website and look back at previous years. There are normally a few housing projects in there as well, and they're always interesting. I think we featured Green Tiles Annex. That was one, Colin Rice, on the podcast not so long ago, but all sorts of interesting things. And this is really useful if you're in your research stage, because researching's the fun bit, isn't it? And finding out what others have done, what they've learnt. That is all on the website. So go and have a look. And as mentioned, we'll put that link into the show notes. So let's get to our featured interview today, which is with Chris Brookman from Back to Earth, all about wood fibre. I started by asking him how he came to work in this area.
Straight after my chemistry degree, literally after my graduation ball, I was dragged out of my student house at about 9 o'clock in the morning to go and start learning how to cob build. And I did that for a few months, did a load of work for my dad, and then worked for a proper cob builder over in East Devon for, I don't know, a year and a half or something, and then set up a business doing cob building. We ran that from 1995, I think, until 2010. Yeah, I did all sorts of different building, and that's what gave me the understanding of construction, because without that, I definitely couldn't do what we do now. And it gave me a really good insight to historic buildings, which is, again, one of our focal points. And yeah, that kind of taught me everything I knew about actual physical building.
Let's just mention it just for a few minutes here. Well, what is cob building?
So cob is a sort of a combination of clay subsoil and straw, essentially. You can add other things to it, sort of sands or grits or aggregates, depending on what the soil is actually like, and you can change the properties of it. But traditionally, it would have just been clay subsoil and straw mixed together by cattle treading over it and glooping it together into a plasticine kind of mix. And then that was stacked on top of a stone plinth, a stone wall. And yeah, you can build quite high with it, actually. Even when it's very wet, you can build up to a metre or so in a day sometimes. And there was a slight tangent to that. There used to be a law that if you built a house on, I think it was on Midsummer's Day, between dawn and dusk, and you got a roof on it and a fire burning in the hearth, you could claim the land. And so people used to do that with cobs. I mean, it wouldn't have been a very tall house, but nonetheless, they used to do that in a day, get the roof on, and there you go, they could claim the whatever land they were working on. But yeah, it's a process that's used all the way along the south of England, all the way from Cornwall up to Kent. And a lot of the old buildings that you look at, the old cottages, that kind of thing, are often made out of cob or some variation of.
Now, you're not a cob builder today or selling related products, if there are any. I don't know whether you're just digging them up. So what happened then?
There are lots of you can still buy cob blocks and things like that, and there's clay blocks and things like that you can buy as well. So I moved away from cob, partly because it's incredibly hard work. And as you get older, you probably don't want to be doing such hard work, being completely honest. But also, we set up the materials business, and my interest really, and because of my chemistry degree, I'm a bit more geeky like that. I like to learn lots about materials, and actually selling the materials allowed me to do more of that. And yeah, bit by bit, we kind of moved away from the building business and then sold the building business off and just focused on the materials. And that's more my passion, which I guess is why I'm still doing it rather than looking at shelving it like I did the building business.
So was it a gradual thing that you came to focus on wood fibre?
It was, because I was very much focused on cob originally. And I guess after about, well, not that long, I suppose, it's sort of 5 years or so, I began looking around for other kind of related materials. And Neil May at the time at NBT was selling wood fibre, and it kind of piqued my interest because it was natural materials and it worked well with cob. That kind of got me moving in that direction, and that's kind of what did it.
So you used it on some of the cob buildings that you were building?
Yeah, when did we use it first? I think we used it. We did. We used it on actually a museum in Topsham in Exeter. That was one of our first projects, and we supplied a few other builders with it as well. And the thing that really interested me about all these materials that are actually available that I didn't actually know about at the time is they are really just a modern form of quite a traditional material. And that's the thing that really interests me particularly, is finding materials which do all the things that traditional materials do, but they're in a modern format so that a modern builder can go pick them up and knows what to do with them.
And when we come to talk about it as insulation, it's not really just one thing that it's doing, is it? It's not just the thermal properties. You've got all sorts of things going on.
Yeah, there's so many other properties to it that actually thermal insulation is almost a side issue, really. The acoustic insulation, the thermal mass, the decrement delay that you get with it, the sort of prevention of overheating in the summer, or reduction in risk of overheating anyway, the ability to lock up carbon for the duration of its lifetime, I think is a really important point. Some people market that as carbon negative. I guess it's not technically carbon negative, but it's certainly carbon storage, no different to carbon sequestration in some ways. And yeah, I mean, even down to things like the fire resistance of it is really, really very good.
And how does it begin its life? I think wood gives the clue, but what is actually happening? And I believe that you can have different ways of combining it.
Done your research, haven't you? Well, there's different ways of making it. So first of all, you're taking, and primarily wood fibre was a solution to the problem of waste wood. So when you're manufacturing lumber, you've got loads and loads of waste offcuts, shavings, all sorts of things. What do you do with it? You can't turn it all into pellets, and you can't burn it and all that kind of thing. So primarily it was a good solution to a problem originally. But yeah, you take your waste timber, you grind it up, you fiberize it. Then you've got two different ways of doing it. So the more traditional process was to mix it with water and detergents and separate that out, turn it into a slurry. You pour that onto a sieve, effectively onto a conveyor belt, strain all the water out of it, much like you do paper, and then you compress it, and then you steam it. And when you steam it, the natural lignin around the fibres glues all the other fibres together. And you normally get a 20 mil-ish thick board, and you laminate that up into different thicknesses. With the more modern process, which is called the dry process, you use a polyurethane-based glue instead, which I appreciate and probably a few people will object to, but it does massively reduce the amount of energy that you need to make the product. So it helps with the amount of carbon that it will lock up. You take your wood, you dry it, you fiberize it, and then you blow it with this polyurethane glue, and you pour that onto a conveyor belt and compress it to the right thickness and density. And then you just cure it with just warm, humid air, so it doesn't need a lot of energy to steam it, and then process all that water as well again that is involved in the wet process. And you end up with a homogeneous product at whatever thickness you want. So anything from 20 mil up to 200 mil you can do as a single slab. And it makes certainly a lower density product, tends to be a bit more rigid and lower thermal conductivity as well. And it's generally a slightly cheaper way to make it, which is probably the reason that's how most of it is made.
And does that affect the moisture as well? Because that's one of the key factors of this insulation, isn't it? That it deals with moisture in a good way.
Yeah, so not massively, because the amount of glue in there is minimal. So there's something like 3%, 4% glue. It's really not a lot. And that's in the really dense boards. That's reduced for the lower density boards. But the surface area of the timber fibres is absolutely enormous. And the surface chemistry that is interacting with moisture is, again, quite complex. And yes, in certain circumstances, it's better to use a wet process board, such as internal wall insulation. But in general, the amount of moisture that the wood fibre boards buffer is enormous and generally not overly affected by that glue.
And do you generally find that these boards have a place because of the way that they've been processed, that they're normally used in specific roles, or can they both be used anywhere?
They can generally both be used anywhere, and most manufacturers will just go with whatever they produce and say, well, you use that everywhere, and they'll produce a board that does X, another one that does Y, and another one that does Z. Quite often it's exactly the same product, but they call it something different and market it differently. We tend to take a bit of a different view because we're a bit more independent. So we look at what products people produce, and we buy from 4 different manufacturers. We look at the products and see what we think is going to produce the best result. We use tools like Woofy to simulate different products, and we can see what is going to do the better job in certain circumstances. And we pick and choose those products and then specify them accordingly. So generally, the boards can be used interchangeably, but we tend to recommend only using the wet process boards for internal wall insulation. Other than that, yeah, you can use them interchangeably.
I probably know the answer to this question, but is anything coming from the UK?
Not a lot. There is a company who's sort of reprocessing MDF, and they, in theory, could produce, wood fibre, and I'm not 100% sure what they are doing with what they produce. The scale that we use the product is just not there yet. So, for example, last year, probably 2 years ago now, Styco brought a new flexible wood fibre factory online. It produces 750,000 cubic metres of flexible wood fibre each year. And that year, the UK imported about 22 to 24,000 cubic metres. So that's the whole country. So, yeah, one factory would run for a month and then it would sit there idle for 11 months. So no one's really going to invest that sort of money to to get that sort of return for the minute. In theory, there's no reason why we couldn't produce it here. But because of the size of the country and the size of the market, it's more likely to be produced in Europe for the time being.
Now, what if we want to use natural fibres, but you've got a few choices? So what draws us to wood fibre?
Okay, so we choose the materials that we choose because of the properties that they have. It's nice that they're sustainable, and obviously we would prefer products to be sustainable. But fundamentally, natural fibre products just work better in most scenarios than synthetic materials. So we're being fairly pragmatic about our material choices and saying, well, what's the best material we can actually get for whatever role? Well, actually, for insulating timber frames or insulating roofs or for internal wall insulation, wood fibre has some incredible properties that make it literally one of the best materials you can possibly use. There are lots of different natural fibres. The reason that we tend to go with wood fibre is the density, because most other natural fibres just don't get produced at the same density. They're much lighter, and actually density makes a big difference to the summer comfort in a building. If you've got a really, really lightweight building, it tends to get warmer quicker. If you've got a much heavier weight building, it tends to warm up much more slowly and tends to give you a more comfortable experience in the summer.
So this could be a good point then to run through your own home, which we're sitting in at the moment, which was one of the early passive houses in the UK. But yeah, how did that begin? What was the start of that journey?
Okay. So the driver was my first son, who was born disabled, and we outgrew our previous cob house because it was, as most old houses are, they're small rooms and there's no circulation space for wheelchairs and all that kind of thing. Over 3 floors, that one was. And so that got us looking at building a new house. When we were starting that journey was also just after I'd really started using and doing more research on wood fibre. And there'd been a few passive house projects around at that time, and John Williams up in Wales had just done one of the first early passive houses there. And that kind of piqued my interest because, again, if you're sat in a wheelchair, you're not active necessarily. Your environment needs to be quite warm to keep you warm. And the thought of trying to, our previous house, whatever that was, 15 years ago, used to cost us about £500 or £600 a month in the middle of winter to keep at a sensible temperature. It was just the most horrifically unthermally efficient house going, or thermally inefficient. So yeah, we were looking at obviously ways to keep our heating bills down, and passive house just really piqued my interest. And And we had the opportunity to do it. We started working on a project called Perryfields, which is in Portland, which was a 72 passive house scheme. And so we were talking to the architects and everything about that project, and then talking to them about our project. And that's how it all got going, really. Then in 2011, we managed to find a suitable house. It was unfortunately a 1950s bungalow, but it did make very good hardcore for the current house. So that was recycled into aggregate for under the basement and under the office. And we started building that in 2012 and moved in early 2013. So there are a couple of things that I would do differently, but by and large, it's worked extremely well. And as a building, it uses very little heat. We spend about 50 quid a year on heating, which for a 400 square metre house is pretty good going. The air tightness has lasted well. All the doors and windows and all the seals and everything continue to do well. It's always comfortable in the summer. It's done well.
Focusing on the disability design for a second, how did you research that, and did you get that aspect right?
Mostly. We mostly got that right. We used an architect who specialised in that to go over the designs that we had and sort of make suggestions about circulation space and door widths and accessibility and the whole plot. Actually, we levelled the plot. So literally from one side of to the other, there's about a 200 mil fall or something. So there is at least a little bit of somewhere for water to go. But all the thresholds are level. All the doorways are at least 900 wide, I think. The most annoying and biggest mistake we made was actually the front door. So we cut a metre wide opening into the frame and didn't realise quite how thick passive house doors are. And with the frame and the thickness of the door, we ended up with an opening width that was only about 740, which made it really difficult to get in and out with a wheelchair, which was kind of ironic as that was the front door. We did have to make some changes. We did that, I don't know, probably 5-6 years ago now, and put in a 1300 wide opening, which gives us about just over a metre clear in the front door. And we also had to change 2 of our clear story windows to electric openers, because you do need to be able to purge ventilate a passive house. Just relying on the ventilation system is not enough to ventilate it in the middle of summer.
And the actual construction of the house, was this something that you got back into old ways, or did you bring in someone?
No, definitely not. No, I've done my stint of building for one lifetime. No, we had a friend actually who lived in the same village that we were living in, who's a really good builder, and they built the office first as a sort of a bit of a trial, and it didn't make many mistakes on it, to be fair, just a few. We got that air tightness down to just over 0.6, I think it was. So unfortunately, it would have been a fail on that. But then on the main house, we got, they really focused on the air tightness. We went through all of the detailing a lot. I worked a lot on the detailing and, running through everything on site pretty regularly, but I wasn't physically here building anything, so that would have half killed me, I think.
It's always interesting. Sometimes when people have 2 buildings on a site, one will be passive house and then the other one will be just their office building. But well done. So you managed to do the 2 together and do that as a set-up one as well. Well done.
Absolutely.
Nice.
A good training platform.
When you were looking at how you were going to build this, we know that we've been talking about wood fibre. So does that lead you necessarily to the build system? What is the approach, and does this actually end up being a common approach?
I think timber frame and wood fibre kind of work hand in hand. If you're building from scratch, if you want a relatively quick build, if you want it well insulated, they're a natural pairing. And to get the kind of U values you need for passive house, it's pretty difficult to do that with masonry plus something else. And also making it airtight is quite a challenge to do it like that as well. I know there's people that build block walls and cavity construction and manage to do it, but timber frame with OSB on the inside was quite a good way forward. We then added other materials like clay boards to it as well to boost the thermal mass. So we've got in total, I think, about 20 tons of clay board in here as well. But those materials all kind of work hand in hand together.
So clayboard, you mentioned about OSB, that is the air tightness barrier, and the clayboard is going where?
So the clayboard was used for acoustics in all of the internal partitions. So We've got a mixture of structural and non-structural internal partitions. The structural ones have got Thermacell on one side and then clayboard on the other. The non-structural ones have got clayboard on both sides and then flexible wood fibre in between. Because the one thing that we found with passive houses that because you need to have a little gap under the doors is that acoustically they tend to be pretty awful. So you have to try and do everything you possibly can to limit sound transfer from one room to the other. So we've lined all of the partition walls with clayboard to boost that. And that was primarily about acoustics. The unintended benefit has been that we've got so much more thermal mass that we just don't get issues with summertime overheating. There is enough sort of thermal storage within the building. Even when it was 35 degrees outside, was it last year or the year before, it never went above 25 inside. So it works well.
And I think I saw you say there were a couple of things that you would do differently. What would those be then?
Mostly just practical things, like we were walking past the ventilation duct at the outlets at the time. We put those on the north side of the building, and they're whatever they are, a couple of meters apart, 3 meters apart, something like that. If I did that again, I would probably put the outlet a lot further away. It's quite noisy, and also because we dry our laundry inside, the amount of humidity that's coming out of that vent is pretty significant as well. And it actually causes black mold to grow on the surface of the pavers around the outlet, which is disappointing. The inlet's fine. I mean, the inlet isn't a problem at all, but the exhaust needs to be further away and somewhere where you're not going to get an issue with surface condensation and black mold. Yeah, that would be one thing. And as I said, the clear story windows, we had to swap those for opening ones. When we built the house, I thought that the ventilation system would deal with it, but it definitely doesn't. Yeah, and doors. But other than that, actually one more thing, liquid screed. Fantastic at transmitting sound. So if anyone's walking around with hard shoes, or if you're trying to be quiet anywhere, people at meters and meters away, the other end of the house, can still hear what you're doing, which is quite irritating. So no, we'd intended to use underfloor heating tiles at the time, but it was looking too expensive, so we went for the cheaper liquid screed option. But in retrospect, I probably wouldn't do that again.
And a lot of this is baked into the time as well. You were an early adopter, and you're gas here, aren't you?
Yes, and again, we at the time, grid electricity was about 500 grams of CO2 per kilowatt. Gas was 180. So we thought, we'll bring up a gas main. It cost us a fortune to bring the gas main up. And now everyone's moving to electric. We still haven't recovered the cost of bringing the gas main up, and we'll probably switch to electric at some point soon.
Yeah, I have a
very one on the chin.
similar thing with my house, where I thought I was almost putting it in for future users who might demand it, which was just silly thinking, but there you go. Okay, let's come back to Earth. So what do you do at Back to Earth if you had a sales pitch for someone?
I try not to do too much in the way of sales pitches, but
you don't have to then. What do you do at Back to Earth?
So we sell materials, but primarily we create specifications, and that's the bit that I actually really enjoy doing. So we've been lucky enough to be doing it for quite a while. We've come across a lot of different materials in that time, and so we've got a good palette of materials together. But primarily we're creating specs to make the most comfortable buildings, or the healthiest buildings, or whatever it is we're trying to achieve at any particular point. And primarily that's what we're selling. We're selling specifications. We sell the materials obviously to fulfill the specification, but essentially we're problem solvers. We use a lot of different software tools for things like internal wall insulation or tricky details. And so we model those just to make sure that what we're saying is actually going to work. And then using the experience that I've got from building and the time that we were actually installing wood fibre insulation, we've got a whole load of details that we can put to go with all the systems that were, all the specifications that we're putting out there. So yeah, primarily we're sort of a specifying merchant, I suppose. And
you are also providing some training, aren't you? That's something that you've revised a few times, and I think you're not on another version of trying to make it as simple as possible.
Well, exactly that. And I think there's a lot of people out there that would use more natural materials if they understood them better. And yeah, we've just launched a new training platform, which is again a revision of the previous one, but we've now got a lot more content on there, just all the 3D models. We've got Ethan in the office who for the last couple of years has been building all sorts of different models of every permutation you can think of, partly for customers, but also to build installation guides and all that kind of thing. But we've put all that onto a training platform, and it's really just a place where certainly I can offload everything that's in my mind that people can access freely without me having to try and remember what it is I know, and then just have a resource for anyone to use as well. And it doesn't have to be for the brands that we use. I mean, the wood fibre that we sell is fairly generic, so you can install Pavatex or Styco or whatever in many of the same ways. So yeah, it's primarily a way of just helping to boost the industry and get more and more people to actually use the products confidently.
Now, dare I bring up the subject of cost? If we use natural fibres, are they just going to be more than the alternatives, or is that a bad way of looking at it? Should we also be thinking of everything that we're getting with them?
Lovely weather outside, isn't it? No, the materials themselves generally are a little bit more expensive, but quite often you're comparing apples with rotten eggs. So my favourite analogy is, why would you use this instead of PIR? It's like, well, how are you installing the PIR? Are you just cutting it, and stuffing it between two bits of timber, or are you actually installing it properly? And so often the perception is that modern materials are cheap because actually most of the time they're just installed incorrectly, whereas we're quite firm about making sure people install stuff properly. All the guides are pretty detailed, going through all the air tightness layers and the whole build up, so you actually get a product that actually works. And so that's part of the challenge. The other part really is getting an understanding of the benefit of, or putting a value to all the other benefits that you get with it. So if you just look at cost, you would only ever use a very small pool of materials. But if you then include comfort, if you then include, your environmental impact, if you include the health of the installers and the health of the occupants years down the line, the longevity of the building, the longevity of the finishes, there are so many other aspects that using, well, particularly wood fibre, but natural fibres generally, affect that's where the real benefit comes. But yeah, if you speak to a QS and all they're looking at is just how much is this project going to cost to build, I know that's a few percent more expensive. Well, that's that. Yeah. There's no understanding of the value of all the other benefits in there.
And also, when we look at the performance gap, are these materials just a bit easier to work with? Some of them that you're not going to get huge, great gaps in between the insulation. Well, I mean, you probably could if you tried, but it's easier.
Well, exactly that. And the simplicity of particularly wood fibre, but the way that you build with it, you're using compressible materials. You squash them and push them between studs. You're using tongue and groove boards that don't shrink, that you don't have to tape the joints on, that, all sorts of different things. So PIR shrinks. Most people don't know that PIR shrinks. I mean, it doesn't shrink a massive amount, but if it shrinks a bit and opens up air gaps, or if it's just wedged between timbers and then shrinks and falls out, that's a massive problem. And so the performance gap that you tend to see is usually all about air gaps. It's air gaps between the inner surface, whatever that surface is that you're trying to insulate, and the insulation itself. And the more air gaps you have, the more thermal bypass and air moving through the structure you get, and the bigger performance gap you get. So, yeah, making the construction method as simple as possible is absolutely the way forward to achieve a good result.
Is most of your work new build, or is there a growing market of retrofit?
Actually, most of our work is retrofit. That's where we've done fairly well with all of the woofy work that we do. People have begun to see the value in what we do with that. And yeah, we do all the hard to treat buildings and the ones that people look at and think, how on earth are we going to insulate that? And so we've got Andy Bannister in the office as well, who's really experienced using woofy. And between us, we work through a lot of really awkward projects and hopefully come up with some good solutions.
So is that extra, or is that something you're doing for the confidence of specification?
So when we specify, we stand behind the specification. So the woofy work is, as much as anything, our own due diligence, because if we're going to say that is the spec you need to use, we need to be able to validate that assertion with something. So no, mostly we, for all the projects that we work on, we would do that as part of our day-to-day assessment of the project. We can do that for other people on different materials, but most of the time we're too busy to be able to do that, and we tend to only concentrate on our own projects.
Now, as we come to a close, is there a specific thought or something, a message you're trying to get out there, either mentioned or not mentioned?
In Europe is a long way ahead of us in terms of the amount of natural fibre materials that they use. So it's not that there's a limit on the amount that can be produced, or there's something fundamentally different between here and Europe. It's really about perception and accessibility. Everything that we can do to improve people's understanding of products, i.e. through the Fibres Academy training platform, through simple detailing, through just making using the products as easy as possible, can only push the market forward until we get somewhere near Europe. And generally, as a share of the market, Europe is using about 10 times more natural fibre than we are. So this was a few years ago, but they were at about 10% natural fibre. We're probably struggling to get to about 1% market share for natural fibre in construction materials. So yeah, everything we can do to push that agenda is going to be good.
Is that because major developers control most of what goes on? Is that the reason, or are there other reasons?
We're in a situation where, yes, the major developers do build stuff, but we buy what they build. If we didn't buy it, then they wouldn't be able to do it. So we've commoditized housing in a different way to Europe. People buy and sell houses with the expectation that they will always make money out of it. It's, you're not buying a home necessarily. You're buying something you live in for a few years, you stick a lick of paint on, and then hopefully make some more money out of. And so I think there's a disconnect between the way that people really look at their houses and look after their houses and what they want from their houses. And I think if people actually wanted more from their houses and actually wanted to be comfortable and didn't always expect to have to make a return on it, they would think more about it, and they would probably change the material choices that are used as well. So ultimately, it's down to what people buy and what they want.
Yeah, demand and also building regs. Those are the two ways that we'll see proper change, if it's legislated or
absolutely.
If we...
I think the government needs to legislate, because they are there to guide people. They're not there as a passive overseer. They are there to guide people's activities, and the only way to really make a big difference in the emissions from the construction industry is to legislate about what can and can't be used.
Would it make more sense to involve natural materials, in inverted commas, whatever we call them, bio-based materials, within regulation, or would that get complicated?
I think the embodied carbon, the carbon emissions from manufacture, and certainly biogenic stored carbon should be assessed in different products, because again, I talk about the locked up carbon in wood fibre, and everyone says, oh, but at the end of its life it's released again. But the benefit is that it is locked up. Having something locked up now is much better than it being not locked up now. So the more you can lock up and remove from the atmosphere now, the less warming impact that has. So yeah.
And make buildings last, because sometimes the design life is woefully short.
Absolutely. Yeah. You can't build a building in the scale that we build buildings and then expect in 50 years' time to be knocking it down and building something new. That's just completely crazy.
Chris, it's been lovely to catch up. Thank you so much for your time.
No problem. Good to speak to you.
Head online to take a look at the show notes that accompany this session, houseplanninghelp.com/371, where you can review the key points once again, because we always provide a summary of these conversations. There are also photos to take a look at, whether it's wood fibre to see what it looks like as a material, or what it looks like when it's installed within, say, for example, Chris's own house build, how that might look. So we've dotted some of those through the show notes. Maybe you've got a comment or you'd like to ask a question. You can do that by scrolling down to the bottom of the show notes, or tap us up on social media. We'll give you links to that and links to Back to Earth. houseplanninghelp.com/371. A couple of asks here. If you've enjoyed this podcast, don't forget that you can review it wherever you're listening. Normally, the app that has given you this episode will also allow you to review the podcast. And we love these reviews because they help identify what the podcast's about, so other people come along and they know straight away. So if you can help us, that would be massive. Thank you so much. And then the other thing is, this is not the only thing I do, the podcast. I also run the Hub, and this is a membership community. Again, the idea being we're continuing the learning. So we do that with a few different tools. For example, I could actually point to this one. We had a live training session with Chris Brookman. This is going back probably a couple of years, but I doubt very much whether it's out of date because it's all on those benefits. We really dig into the benefits of wood fibre. So that could be something to come and check out. We've got all sorts of different experts who lend us their time and their expertise, which we absolutely love. We've also got a feature called Ask the Expert, where you can get your specific questions answered on various different topics. We've got courses. We've got a forum where you can just tap up everyone else who's involved and find out what they're doing on their projects, find out what they know, what you can bring to your own project, or you can learn from me as well, or chat to me, or offload on me in office hour. That's a weekly call as well. So all sorts of things going on in the Hub. Find out more information at houseplanninghelp.com/join. Next time, Catherine Adams from Reusefully and Connie Spohr, Self-Builder, are my guests. We're going to explore the topic of reuse. Thank you so much for listening. The House Planning Help podcast is produced by Regen Media, content that matters.